Hello everyone, this is Jay from BTYT Tech Library. Today we are going to solve LeetCode problem number 3, longest substring without repeating characters. Given a string S, find the length of the longest substring without duplicate characters. In the sentence, a substring is a contiguous non-empty sequence of characters within a string, and it's our hidden key to solve the problem. Let's gain a deeper understanding of the problem through examples. In the example of ABC, ABC, BB, the answer is 3. But how can we tell? Depending on the cultural context, we might scan the string character by character from either the left or the right. If a character already exists in the portion we've scanned so far, should we restart the process from one character after the initial starting point and continue checking in the same manner? The constraint that there must be no duplicates and that the series must be continuous without any spaces liberate us from the tedious task of performing a full search from one end of the string to the other each time, much like the back and forth motion of an accordion. As a more efficient method, we can place 2 pointers at one end of the string and move the expedition one step at a time toward the opposite end. We check whether each character exists in the string that has been scanned so far. If the character is not found, we add it to the newly discovered string and continue moving the expedition. If the character is found, we stop the movement of the expedition, advance the base by one step, and remove the character at the current position. By updating the length of the longest string during the search in this way, we can solve the problem with a time complexity of big O of n. Let's code it up. First, let's handle the edge cases where the length of the string is either 0 or 1. After defining the position of the base and the expedition, and the variable for tracking the maximum length, we begin by adding the first character to a set, which will store only unique characters. As long as the base does not collide with the expedition, and the expedition's journey does not exceed the total length of the string, if a new character is not found in the current set, we add the new character and continue the expedition. If the character is already in the set, we move the base and remove the character from the set, then continue exploring the entire string. When the exploration ends, we return the maximum value. Let's run the code. That's it. In computer science and programming, the two-pointer and sliding window techniques are super popular. They are used to solve problems that can be solved efficiently by keeping track of two positions or indices in a sequence or array.